Hi, I'm Sakshi. This video is going to summarize the sections 9.1.2 through 9.1.5 at a very high level. More details are in the final report of the project. So if you look at this in section 9.1.2, the problem statement to solve was to clean the data set by replacing the commas found in the values of the order attribute product name with the hyphen, because the reason being that comma was creating a problem in the data analysis, because commas were present in other attribute names as well. So that comma needed to be replaced with hyphen. The steps that were used to resolve the issue was using the GREL expression query language. This query value dot replace comma with a hyphen. This separated the product name to the desired format. The tools used to pre-process this data was Excel and OpenRefine. The outcome was that a cleaned brand new data set was obtained, and it was already pre-processed, and it's now ready to be analyzed. Okay, the next section 9.1.3 dealt with another problem wherein we had to clean the data set by fixing the typos in the state zip code of the data set. Some of the zip codes were found to be either having a typo wherein one of the digits was missing. So 4-digit zip codes were found instead of five. So this was assumed that it was a typo or incorrect zip code was listed in the data set. So if we continue the analysis using 4-digit zip code, it could lead the data and analysis to be misleading. So this needs to be cleaned. The steps that were used to resolve was similar to steps in the prior slide. There was a query language or GREL query that was used to fix this typo issue. The query is listed here. If value length is greater than 4, which means if it is 5, then retain the value, else change it to a dummy value for the zip code, which is 99999. So this query language helps to make queries that can clean up or reformat the data set. Or any attribute in the data set. Again, the tools used were OpenRefine and Excel, and the outcome was that the data set, clean data set or pre-processed data set was obtained, which is now ready to be analyzed. This is a very important slide. I've put this because this is one of the main pieces, very important pieces that I've learned in the course ADTA 5240 about the data stages. So to validate, cleanse, deduplicate, or enrich data, is one of the very important steps for data analysis. So if you see here, first the requirements are collected. The data collection happens from different servers. Data is processed and cleaned before it is analyzed, and finally an output is obtained. So it's one of the important steps, as I mentioned, and 80% of the time is spent in cleaning the data, which is called exploratory data analysis, EDA. This step could be mundane, but it lays an important foundation for data analysis. So this is the different stages of data. The data life cycle, you see again from the previous step, 80% of the time goes in data preparation, which includes data cleaning, error detection, error repair. Many tools are available online, some open source tools as well that can help in the data cleaning process. Tools like Tabula, Excel, Google Data Prep, OpenRefine, Excel, NumPy, Python, Matplotlib, Plotify, and R, All these are some of the tools that can be used for data cleaning and preparation, but I used Open Refine, which we did it in the class, and it makes it easier to explore large data sets or large sets of data and support various formats. So it has many features like clustering, grouping, etc., that has been really helpful in doing data cleaning in my data sets for this course. The next three sections, which is 9.1.4 and 3, 4, and 5, basically, it dealt with the Apache Hadoop ecosystem with Hive and Spark. And the problem that I was trying to resolve here was use Spark and Hive queries to find out the top 5 states with most customers from the data set and top 10 postal codes with maximum sales from the data set, and compare the outputs using Hive and Spark queries. So steps that were used to resolve this was both Hive and Spark queries were used, and the results were compared. The tools used for data cleaning the data set was Open Refine, and the outcome for this problem or analysis was that the only difference that I found was when the Hive and Spark queries were run, there was a difference in the speed for running the queries, and Spark's queries resulted in much faster output than Hive. This is again very important information about the Spark, that Spark uses in-memory computation. The data is kept in random access memory, which is the RAM, instead of slow disk drives, and is processed in parallel as compared to Hive. And using this, we can detect a pattern, analyze large data sets. And this has really become very popular because it reduces the cost of the memory, right? Which is very important for any organization. So in-memory processing is used in Spark. So very economic for applications in any company. So this is a reason why Spark, when compared to Hive, gave much faster and quicker results in comparison to Hive. This is a sort competition that was performed using Hadoop, MapReduce, and Spark. And as you can see, when considering number of nodes, number of cores, cluster disk throughput, network, sort rate, etc., time and data size, everything, the Spark was 3 times faster than using 1/10 of the nodes. So this definitely tells us that if there is no uh, issue with the cost and data size, then Spark is the best option available to choose between Spark and Hive. But both are meant to not compete but complement each other. If both, there are many companies and organizations where I've seen both Hive and Spark being used together instead of choosing one over the other. Thank you.